As we grow older, everyone wants to live an active and healthy life until the later years. However, with declining physical abilities, we need technical innovations to support us. At the Chair for Medical Information Technology, we are researching exactly these solutions within the field of gerontotechnology. Prominent example is the assistive exoskeleton, which compensates for reduced muscular strength and supports everyday activities.
The development of exoskeletons for elderly brings a few particular challenges. Firstly, the gait of elderly people is prone to falls, so we need a lot of sensor information to measure the gait precisely, especially in the feet. Moreover, the cognitive and haptic abilities of elderly people are degraded in comparison to younger people, so we need an age-appropriate donning and user concept. Lastly, the skins and bones are more brittle compared to younger people, so we need a soft and fluid force transmission from the exoskeleton to the user to have a benefit for the elderly while using the exoskeleton. This requirement led to the master thesis of Carlo Yacoub.
My thesis soft actuator for exoskeletons was about designing a variable stiffness element for the exoskeleton's knee joint. To kind of grasp the concept of variable stiffness, we can compare the human joints to robotic joints. Because human joints are already variable in stiffness. So if you keep the muscles loose, the joint is also loose, but if you contract the muscles, the joints turn stiff. Robotic joints, on the other hand, are constant in stiffness. This is great for precision, but when man-machine interaction comes in place, we need the robot to be also compliant to increase more safety. And therefore we designed and built a pneumatic damper for the exoskeleton leg. Because if we increase the pressure, the stiffness increases, and if we lower the pressure, the stiffness lowers. But now the damper needs to know when to turn stiff and when to keep loose. Therefore we used a sensor kit in the sensor shoes to perform a gait phase estimation and an intention estimation of the human in there. And thanks to the Hans Hermann Voss Foundation, we were able to actually build the exoskeleton leg instead of just handling in theory. For future work, we will also need to design proper control algorithms for the whole exoskeleton to make it safe and ready to use.